going on, everyone? Today we're going to talk about some TypeScript generics with our good friends, the Sully family. We're also going to see some examples here from type level TypeScript as well as type challenges on GitHub, and I will link those both in the description below. So let's do a JavaScript recap. Functions in JavaScript have signatures. What is a function signature? This is something that defines the inputs and outputs of a function. In other words, at a glance, it can tell you what a function does without you having to read the entirety of the code within the function to figure out what's going on. A function signature is like a formula. There are two issues with function signatures in JavaScript. Let's take a look at this as an example. We have a function grow Sully family, taking in children and returning children plus 1. So what does looking at this function tell us at a glance? Well, we have a function and it takes in something called children. Apparently later on it returns children plus 1. But what is children? In JavaScript it could be anything. However, by reading the code within the function, we can infer that it's probably a number because we are returning children plus 1, and the function is called grow Sully family. Unfortunately, in this example, simply looking at the function name and inputs doesn't give us a lot of rich information about what this function does. We have to actually look inside the function at the code within to understand what's going on. But what if there was an easier way? One of the ways that TypeScript resolves this issue is by including types, and for that matter, return types. Check out this same function rewritten using TypeScript. Now simply by glancing at this function's signature, we get a whole heck of a lot more information. We can now see that it must take a number as an input and return a number as an output, without explicitly needing to look at this function's definition, in other words, the code inside the curly braces. We can more or less infer what its purpose is and how the pieces relate to one another. And generics take function signatures to the next level. Let's say we have a function that takes in a string and returns an array with 3 instances of that string. Simple enough as far as TypeScript types go. But what if we wanted to change this function so that instead of only being able to take in a string, it could take in a number, or a Boolean, or even a more complex data structure? We want to create a function signature that is more generic. In other words, whatever thing it takes in, it must return an array of 3 of those things. This is the exact scenario that generics in TypeScript are built for. The input and output are variables where the type of the input and the type of the output are somehow related. Let's take a look at this. With a pattern like this, we still get that rich, strongly typed information about what this function does just by looking at its signature, and it can now handle an input of any type. Let's take a look at another example. Here we have a function signature where the types have not yet been defined. This is basically just JavaScript. So what can we infer here? We know this function will need to take in a parameter and return a value which is the same type as the parameter. This is an example of a function that can make use of a single generic value. Here, the first t is best thought of as a representation or guide, which tells us that this function will make use of a single generic value. The second t, used as a type for the parameter a, shows us that the value the function takes in may be of any type. And the third t, used as a return type, shows us that the value this function returns must be of the same type as the parameter it took in. So why are we using t? The truth is, this just tends to be a convention we see used somewhat often in TypeScript documentation. But like any other variables, we can call our generics whatever we want. Sometimes you'll see them called property or p if they're describing a key in an object, for example. For example, here we use p to describe each key of an object. So let's take a look at an example of a function signature which requires 2 generic values. What's the relationship between the inputs and the outputs here? We know the function takes an array of things. That's things, not strings. Here they are strings, but really their type could be anything. This function also takes another function, we call this a callback function, which will execute for each value of the array. So we know that the value this callback function takes as a parameter must be of the same type as each element of the array. We can call this value t. The callback function returns a thing. Its type can be anything and is completely independent of the elements of the array, as well as independent of the parameter the callback function takes in. We can call this second variable u. The function then becomes this. Again, here all we're doing is describing relationships between inputs and outputs. If you're confused here, I recommend pausing the video and leaving a comment below, and I'll answer it as best as I can to the best of my ability. I recommend leaving your question in this format. This is what I do understand already. Here is what I'm trying to do or understand. And this is what I think is happening. And I recommend anyone watching to check out the comments section as well, see if there are any unanswered questions, and as a community, let's help each other out. Okay, just for fun, let's end this video with a bit more complicated example. We have a function that takes in a value, then passes that value through a callback function which transforms it into a different value. This new value may or may not be the same type as the original value. We then take this new value and pass it through a second callback function. The result of this second callback function becomes the return value. Its value may or may not be the same type as the value passed into the second callback function. So in total, we're going to need 3 generic values. If you like this video, share it with a friend. Thanks for watching, and I will see you in the next one.